Thank you so much. There are a couple primary forms of user authentication that websites tend to support. The first is password-based authentication, or PBA, in which you simply authenticate with a username and a password. This is the de facto form of authentication on the web due to its simplicity and intuitiveness. But because passwords are guessable, leakable, and prone to reuse, relying on PBA for authentication is inherently unsafe. So the general advice is then to enable multi-factor authentication, or MFA, in which you present 2 or more factors to authenticate on all of your accounts that support it. And while it's true that enabling MFA substantially raises the bar required to compromise an account, it unfortunately suffers from substantial usability issues that have hindered its adoption by users. So a third form of authentication, risk-based authentication, or RBA, has emerged to help protect users who don't opt into MFA. In RBA, in addition to submitting a username and password, a fingerprint is taken of a user that observes various implicit features in their browser, such as whether a cookie is present, the IP address of them, and their user agent. If the credentials match what is known for that user and the authentication is successful, the fingerprint is saved in a database. And over multiple successful logins, the system starts to develop a notion of what is normal for that user. So then, when the user logs in from a device that is typical for them, the system can detect that the features match what is normal. And so login is allowed successfully using just the username and password. So from the user's perspective, they've authenticated using just standard PBA. However, when they try to log in from a new device, or maybe someone has acquired their account credentials, and so the fingerprint doesn't match what is known for them, in that case, the system can automatically request additional authentication factors, and only once those are provided, allow login to complete successfully. So this helps to protect accounts while preserving the usability of standard PBA. But so this begs the question, what is the state of user authentication security? Because although MFA and RBA are both recommended by NIST, there are several questions that haven't been really answered by prior work. First of all, do sites actually support MFA and RBA? And if they do they support secure factors for them? Because relying on SMS codes are susceptible to SIM swapping attacks, and relying on email codes are not true MFA, but actually two-step verification. And then if sites don't support them, does single sign-on, or SSO, offer some kind of remedy? And what I mean by that last point is that if you take a website like SoundCloud here that doesn't presently support MFA, but has 3 SSO providers that do, then if you sign into SoundCloud using one of those providers where you've enabled MFA, then there will automatically be a request for additional authentication factors. And so you can think of SoundCloud as effectively inheriting the login security of its provider in this case. But so in light of the other research gaps, we put forth a couple research goals and questions. First, we want to perform the largest study of MFA and RBA availability to date. We want to understand what additional factors sites support for MFA and how they respond to a suspicious login attempt. We also want to know how SSO changes the picture and what the implications are of our findings. So moving on to our study methodology, we begin by discussing our scope and site selection. Something we have to discuss up front is that measuring MFA and RBA at full internet scale just isn't feasible because self-attestation of their availability isn't guaranteed. We actually need new accounts for each site, which we control so that we can actually test for these in a systematic way. But trying to automate or crowdsource this account creation process introduces significant limitations. And so we instead focus on a manageably large set of 208 popular sites obtained from prior work, and then perform a systematic manual analysis of each of them. This histogram shows the Tranco rank of all of the sites in our domain, our audit. So you can see there's a substantial focus on the absolute most popular websites with a long tail out to rank 5,000 on the list. To measure MFA and SSO for each of our sites is actually very easy. So for MFA, after creating an account, we simply navigate through the account settings, looking for some reference to MFA or two-step verification, and record whatever factors we see there. SSO is even easier because it's plainly visible on the login and/or sign-up page. So we simply navigate to the login page and then note whatever domains we're redirected to when we select any of these 3 buttons. For RBA, however, there are substantial challenges that need to be overcome, because the only way to tell whether a site uses RBA is to actually observe it directly in response to a suspicious login. Remember, it's supposed to be transparent to users who don't turn on MFA, so it's not under their control to turn on or off. And it's not something that can be gleaned from login page information either. So we actually need to create a new account from one machine, teach the site what is normal for that user by regularly logging into it and interacting with the site from that machine, then attempt to log in from a machine with a substantially different set of features than what's normal, and observe whether or not there's some response by requesting additional authentication factors. And so this gives rise to 2 key questions. The first is, what features do we actually control for? between our training machine and the machine that's supposed to be suspicious. And we base our choice of features on prior work. So we explicitly account for the IP address, operating system, browser, and screen resolution, with the idea that we want to set off as many alarms as possible between the machine that we typically log in from and the machine that's supposed to be suspicious. So we create our account and perform all logins from our training machine, which is a personal computer in Boston, Massachusetts. And then after we teach a site what normal is, we attempt to log in from our suspicious machine, which is a completely different machine with an IP address in Sofia, Bulgaria. The other question we have to answer is, how do we teach a site what normal is for that user? In other words, how much interaction is necessary to both enable and train RBA? How many logins are necessary? And is there any post-site interaction required? And we go into a lot more detail about how we answered this in the paper, but essentially we have a very simple methodology for this. For each site, we create and verify a new account from our training machine, then just simply log in and out of that account 10 times from the training machine, scripting that login with a modified version of Puppeteer whenever possible. What we found is that this is actually as good at training RBA as performing lengthy manual interaction with that site for a week. Essentially, if we just do this simple login, logout process 10 times, then the site's response to a subsequent suspicious login is the exact same as if we'd done everything manually and added substantial account history. And we confirmed this through an experiment with 50 random sites from our set. So, with our methodology out of the way, let's begin discussing our results. First of all, we found that both MFA and RBA are extremely uncommon in general. Just 42.3% of sites in our dataset supported MFA, only 22.1% blocked the suspicious login attempt, and only an additional 11.1% alerted the user to any sort of suspicious activity on their account. We also found that popular sites are much more likely to support MFA and RBA, as shown by this graph here. So this maps the percentage of sites at or below a given Tranco rank that either have MFA in green or that have various RBA behavior in orange and red and blue. And what you can see is that within the Tranco top 10, every single site that we audited both had MFA and blocked the suspicious login attempt. But by the time you reach rank 50, both plots are in nosedive and continue to decrease all the way down to the long tail of our distribution. We found that the most popular MFA factors are SMS OTPs and authenticator apps, supported by 69.3% of sites with MFA in our dataset. 8.7% of all sites support MFA only through unsafe factors like SMS codes and email codes. However, these tend to be less popular on average. And then for RBA, email and SMS OTPs are nearly universal as responses to the suspicious login attempt, requested by 82.5% of sites in our dataset with RBA. But while we found that MFA and RBA are both extremely uncommon in general, we found that SSO completely changes the picture. In fact, if one were to sign up through an SSO provider that supports MFA and or RBA whenever available, then 80.3% of sites on our dataset would have access to MFA, just 1.4% would have access to only unsafe factors for MFA, and 72.6% would block a suspicious login attempt altogether. This graph sort of visualizes that with the number of sites with certain behavior before SSO in blue and after in orange. This is a nice visualization of the SSO relationships in our dataset. So each node in this plot is a website. The purple nodes are sites that did not have MFA, but that inherit it directly from an SSO provider, which has the outgoing edge to that purple node. What you can see is that there's really 4 key players that end up providing MFA to the rest of the web through SSO: Facebook, Google, Apple, and Twitter. It was still Twitter when we ran our study. And we see pretty much the exact same behavior for RBA. But so, is SSO the answer then? Is the solution to this problem just, sign up for SSO through one of those 4 providers whenever possible? And, well, no. There's a couple key drawbacks that need to be discussed. The first is that SSO presents a single point of failure. And so if you are using a single site's SSO for all of your accounts, then compromise of that one account then gives an attacker access to every single one of your other accounts. Another key thing to mention that you may have noticed from those 2 plots is that nearly all of the SSO providers with MFA and RBA are major third-party trackers as classified by Disconnect's tracker list. And so you can imagine that it may not be amenable to all users to use SSO through these providers in all cases. Why create manual links between every single one of your accounts and that of a tracker? They certainly stand to benefit a lot from that. And so if you actually exclude all third-party trackers from the list of available SSO providers and recompute the MFA and RBA availability statistics, just 56.8% of sites now have access to MFA. Just 45.7% would block a suspicious login attempt. And really the only provider left with any sort of significant coverage is Apple. So SSO is not a silver bullet for improving login security. So given that, how do we improve this situation? Because ideally, every site would both offer MFA through secure devices and use RBA to protect users who won't opt into it. So we reached out to all 161 sites in our dataset without MFA and or RBA and asked them why they didn't support it. And though we heard back from just 4, the feedback was rather illuminating because they all made references to the same key ideas. Some really pushed it onto users and said that MFA isn't important because it's users' job to choose strong passwords and use password managers instead. And others said that they would consider adding it, but only if their users actually want it. And they just didn't see a strong enough user demand for MFA and RBA to actually go through with it. So the key takeaways for the security community is that we still must work to change prevailing attitudes about relying on passwords for website administrators and users. And while end users certainly benefit from knowing that SSO can provide MFA and RBA for their accounts, it doesn't end there, because users' attitudes towards security must also change. Only a preponderance of users requesting these types of security features will actually encourage developers to support them. So in conclusion, we presented the largest study of MFA and RBA characteristics to date. We found low adoption of both in general, but that a supermajority of sites can access both MFA and RBA through SSO providers. But because SSO is a single point of failure and may pose privacy risks, prevailing attitudes towards password-based authentication must change to make the web more secure. Thank you so much, and I'll take any questions at this time.